Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson on exponential functions and their graphs. In the last lesson, we built tables of values for exponential functions and learned the properties of their graphs. Today, we will learn about the irrational number represented by e. We will also learn about the natural exponential function. Are you ready to get started, everyone? We are already familiar with the concept of irrational numbers. If I asked you to name an example of an irrational number, you would probably say pi. This is a good example, but now we are going to learn about another irrational number, e. It is very important in the field of mathematics. E is the number that 1 plus 1 over n to the power of n approaches as n approaches infinity. Like pi, e is a number without end. It can be calculated to an infinite number of decimal places. How is the number e used? Let us look at an example. If a person has a savings account with a bank, the bank pays interest on the balance of the account. If the bank calculates interest once a year, this is called annual interest. If interest is calculated once a month, this is called monthly interest. Some banks even calculate continuous interest. Let us see how 1 bir grows for 1 year at 100% annual interest. We must use the formula amount A equals principal times 1 plus interest to the power of the number of periods. P represents the principal. So in this case, P equals 1. The annual rate, R, is 100%. If there are n periods of compounding per year, I equals 1 over n. The amount after 1 year is given by this formula. A equals 1 plus 1 over n to the power of n. Let us use our formula to calculate how different periods of compounding will affect how much interest is earned. If interest is compounded annually, then the equation looks like this. 1 plus 1 over 1 to the power of 1. This equals 2. Therefore, 1 bir will turn into 2 bir if compounded at 100% annual interest. If interest is compounded semi-annually, then 1 plus 1 over 2 squared equals 2.25. 1 bir becomes 2 bir and 25 cents. You see, students, that the more often interest is compounded, the more interest is earned. Quarterly interest yields about 2 bir and 44 cents. Monthly interest yields about 2 bir and 61 cents. Weekly interest yields about 2 bir and 69 cents. Daily interest yields about 2 bir and 71 cents. Notice, students, that the increase in interest is getting smaller as the compounding periods grow more frequent. There are 8,760 hours in a year. Hourly interest yields about 2 bir and 72 cents. Now, the increase has gotten so small it can no longer be expressed in bir. These are the equations for interest that is paid every minute and every second. You see that as n grows larger and larger, the amount after 1 year tends toward 2.71828182459, and so on. That is to say, it tends toward the irrational number e. It is time for an activity, students. This is a function involving the number e. Construct a table of values, then graph the function.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Here is our function. These are the values of y for each x. These are certainly complicated numbers. But notice the relationship between x and y. We can already tell how the graph of this function will look. Here is our table of values. I hope that yours looks the same as mine. If it does, then we are ready to make our graph. Let us plot each point. It is difficult to be very precise with numbers that have this many decimal places, but we must do our best. Now we draw the line of our graph. If yours looks like this, great job! This is called the natural exponential function. Let us do another activity, everyone. Using your graph, please answer the following questions. I'll be back in a moment.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. I'm sure you were able to answer each question. The domain of the natural exponential function is the set of real numbers. The function's range is 0, infinity. This means that the line of the function never intercepts the x-axis. It is an increasing function. As you can plainly see from your graph, the natural exponential function intercepts the y-axis at 0, 1. It has this in common with all other basic exponential functions. E to the power of x is thus greater than 1 if x is greater than 0. It is less than 1 but greater than 0 if x is less than 0. This is all for this lesson. We have learned about exponential functions and the properties of their graphs. We have also learned about the irrational number e and its properties and uses. Until next time, thank you, teacher. Thank you, students.